this video we're going to be solving three different problems. Okay, now the reason why these problems are specifically selected out is because in terms of vibration, where some students are asked to find velocity or acceleration, okay, in which the solution will require you to differentiate equations like this, most students tend to fail it. That is why I have specifically selected out these three different equations, okay, and they are to be differentiated under the rule which is function of a function. Okay, the reason why we call it function of a function is because every parameter is a function of the other in this case. Okay, in this case displacement is a function of time, okay, and then we're having other parameters outside like y, which is a function of what now? Displacement, and a function of time. So we have function of a function. Okay, now to differentiate this, we'll apply our basic rules on differentiation, of which I'm going to be using them to solve these three equations, and I do hope that it makes it easier for you to answer more questions that are done like this. Okay, now I'm going to start with the first one. So for the first one, we're having y equals 0.2 sine 0.25 pi in bracket x minus 50t. Okay, so here's our equation: y equals 0.2 sine open bracket 0.25 pi, okay, in bracket x minus 50t. Now to do this, first things first, go to the innermost bracket and I want you to expand it. That's the first thing I want you to do. So in this case, I'm going to have y equals 0.2 sine 0.25 pi times x gives you 0.25 pi x minus 0.25 pi times minus 50t. Now 0.25 is 1 over 4, right? And 1 over 4 times 50, that's 25 over 2, which is 12.5. So you have minus 12.5 pi t. Okay, that's what we're going to get. Now let's differentiate this with respect to t. To differentiate this, differentiating y, we get dy over dt. Okay, that's the first thing you're going to get. This time around, it's not dy over dx. Okay, it is dy over dt. Even if there is x in the equation, because the equation it wants us to differentiate with respect to t. So I'm going to write with respect to t. Okay, for all of them, except I said with respect to x, that is when we're going to have dy over dx. Okay, so in this case we are differentiating with respect to t. Okay, so to do that, we're going to have dy over dt equals, first things first, we'll come into the brackets. Okay, step one, come into the bracket, differentiate what is inside of the bracket. Now how do you differentiate? Any number or any term that carries t, when you differentiate it, okay, we're going to differentiate it normally using the formula. If y equals ax to the power n, dy over dx equals an x to the power n minus 1. This is something you should learn in our other video. I think we have a video on calculus which explains an introduction to these guys. Okay, so you can as well watch that. Now, having that in mind, if we differentiate 0.25 pi x, there is no t attached to this, so it's 0 we are going to get. If you differentiate minus 12.5 pi t, there is t attached to it, so we are going to get the number in front of t. So we are going to get minus 12.5 pi, okay, and there's also 0.2 outside, do not forget, so you have 0.2. Now when you differentiate sign, you should go in calculus, you get cos, that's cosine, so you have cosine, then write the function again, 0.25 pi x minus 12.5 pi t. Now I'll go over it again. First things first, differentiate what is in the bracket, that's step one. In this case, we differentiated this one to be 0, differentiated this one to be minus 12.5 pi, that's what we wrote outside. Initially there's 0.2 outside, so write it. When you differentiate sine, that's step 2 now. Differentiate sine, you get cosine, you write cosine, you write the function again, that's it. Okay, so from here we'll simplify our don't differentiation. So simplify, therefore dy over dx will be equal to, when you multiply minus 12.5 times 0.2, okay, 12.5 times 0.2, that's going to give us 2.5. okay, so get minus 2.5 cosine 0.25 pi x minus 12.5 pi t. Okay, so that is our answer. We are done with differentiating, so it's quite easy. Okay, all we have to do is follow the two steps. First things first, differentiate what is in the bracket, write it out, that's step 1. Step 2, differentiate the trig function. Okay, when you differentiate sine, you get cosine. When you differentiate cosine, you get minus sine. Okay, you write it out as well, and then write out the function. So it's as easy as that. Okay. Now the next question on the board is x equals 5 exponential minus 0.75t sin pi t. Okay, that is what is given in this case. And to do this, we are going to rewrite the equation. So for number 2, we are going to rewrite this equation as x is equal to exponential 5 exponential minus 0.75t, okay, sin pi t. Remember they said as t tends to 0, okay, or as t equal to 0. So I think we are going to substitute for t equal to 0. Now to do this, we are going to make use of what we call the product tool. Why are we making use of the product tool? Simply because we're having two terms multiplying each other, and then each of the term is carrying what we are differentiating with respect to. So x is a function of time, x is a function of time as well, okay, and these two guys are two different entities multiplying each other. Product, that's multiplication. So I'm going to differentiate using product rule. Now the rule for product rule is that if y is equal to uv, then dy over dx is equal to u dv over dx, okay, plus v du over dx. I'm not going to spend time explaining this guy. This is simply because we already have a video, introduction to calculus, where I've explained products using a few questions, okay. So I'm going to have x equals 5 exponential minus 0.75t sin of pi t. Now to do this, we are going to write the first one down, differentiate the second one, write the second one, differentiate the first one. That's what it means, okay. So I'm going to have dx over dt will equal, we are going to write this first term down, okay. Let me bring 5 out, okay, to make it easier. If I should bring 5 out in brackets, write exponential 0.75t down, I have minus 0.75t. now differentiate sin pi t. That's what now function of a function. Differentiate pi t, you are going to get pi. Differentiate sin, you get cosine, okay. So you have pi cos, write the function again, same thing we did here. So I'm going to have times, we're going to have times pi cos pi t, okay, plus, now do the same thing again. We're going to write sin pi t, then differentiate this function, okay. So I'm going to have sin pi t, and then differentiate exponential minus 0.75t. When you differentiate this guy, we differentiate what is on top. So differentiate minus 0.75t, you get minus 0.75. Then write down the function again, okay. So I'm going to have multiplying this is a t. These matters are quite bad. Okay, minus 0.75, okay, multiplying exponential minus 0.75t, okay, exponential minus 0.75t. Now let's simplify our done differentiating, okay. So it's as easy as that. So from here, the x over dt will be equal to 5 in brackets, okay, pi exponential minus 0.75t cosine pi t plus okay, we're going to have a minus simply because of this minus 0.75 exponential minus 0.75t sin pi t, okay. That's what we're simply going to get. Now we're done differentiating. Remember the question said at time t equal to 0. So I'm going to come here and say at time t is equal to 0, we'll obtain anywhere we see t, we're going to replace it with 0. So if we put it here, we get exponential 0. Put it here, exponential 0. Put it here, cos 0. Put it here, sin 0. So sin 0 is what now? 0. So everything on this end equals 0, okay. Now when we put it here, exponential 0 is 1. Multiplying, when we put t here, we get cos 0, and cos 0 is what now? 1. We're going to be having our final answer to equal, this gives us 1, this gives us 1, so we multiply 1 by times 1, you get 1 times pi, that's pi, times 5, that's 5 pi, okay. The reason why this one is equal to 0 is because when we put t here, we get sin 0, and sin 0 is 0, so you multiply everything here, you get what now? 0. So our answer will now be equal to 5 pi at time t is equal to 0. But assuming we're not given a condition whether t equal to 2 or 5 or any other number, this would have been our answer, okay. Now for the third question, we're given x equals 5 cos 2t plus pi over 6. How do we solve a problem like this? Okay, I'm going to do it here. So to differentiate this with respect to time, we get the x over dt, okay. function of a function, differentiate what's inside of the bracket. This one is a constant, pi over 6, differentiate you get 0, okay? Differentiate 2t, you get 2, multiply what is outside, you get 10. Differentiating cosine, you get minus sine. So we're going to have times minus sine, write the function again, 2t plus pi over 6. So that gives us minus 10 sine 2t plus pi over 6. So it's quite easy, okay? If you did not get everything cleared out, let's watch our previous video on calculus, or you could decide to go over these things again, okay? It starts from basic knowledge. I did not make it an introduction to calculus due to the fact that we already have another video that I was explaining the introduction. So for these few examples, I hope you're able to grab and know why whenever a function is differentiated, for example, these ones are equations for velocity, okay? Some are particle velocities and the likes. So when you differentiate these guys, you know what you're going to guess, and you're going to know how the equations are being differentiated using function of a function, product rule, or any other rule you might need to apply, okay? So all you have to know basically is, for this one, we use product rule because two functions are multiplying each other and then in terms of what you are differentiating with respect to, okay? That's simply that for that. And for this one, we're having function of a function. I explained y is a function of x and also a function of t, okay? That is how we're using function of a function. Or basically for trigonometrical functions, we make use of what now? This term, function of a function, and differentiate them like this, okay? Using the basic method we have in differentiating, which includes chain rule, quotient rule, and likes. So in our next video, we'll be explaining more on some of these concepts, and we'll be solving a few examples. Stay tuned, do well to like, share, and subscribe as usual, okay? Click on the notification bell as well so that when a new video is being uploaded, you'll be one of the first persons that get notified, okay? See you in the next video.